Objects. As you might guess, the basic tenet in object-oriented programming is the concept of an object. What are objects? Very simply, they are a simplification or a model of something of interest. You've been using objects from the first day that you could talk. It's just that you probably haven't thought of it that way. Objects are abstract concepts or simplifications of everything that you see around us. In business, we can talk about an invoice object. We can talk about a purchase order object. We can talk about an employment history object. Anything that you can think of that is of the noun characteristic, a person, place, or thing, probably can be modeled as an object. What I'd like to do is just to go through a very simple scenario that maybe some of you have actually gone through yourself, and that's in hiring a new employee. And we'll just assume that one of you is the employee, one of you is the employer, and we're trying to arrange an interview between the two of you. So what we want to do is to have the recruiter call the candidate to arrange a meeting where they can meet at the airport and proceed to do a face-to-face interview. Now, what is the purpose of this phone call? The first purpose of the phone call is to arrange a time when the candidate can come to the company for a face-to-face interview. And actually, the second part of the phone call is to arrange a meeting at the airport so that the person can be picked up and taken to the company for the interview. So we're assuming that the candidate and the recruiter then are trying to accomplish similar tasks, only perhaps the goals are slightly different. What we can do is model a class person. In other words, we're going to create an object of the person type, and we're going to call it class person. Now, you'll notice that whenever I write code, and there'll be reasons for doing it this way, I tend to use a three-letter abbreviation for the class of object that I wish to write. In this case, CLS is the three-letter abbreviation that I use for all of my class code. And then person I capitalize using a modified Hungarian notation. What we're trying to do is decide what kind of information do I need to acquire for me to successfully meet the candidate at the airport. And immediately I start thinking of things like name, height, weight, hair color, blah, blah, blah. We can also talk about clothing, whatever. Now, actually, the person, the candidate who wants to do the interview and get the job is actually doing the same thing. Who's going to meet me, and how are we going to hook up at the airport? Now, we could do the sign thing, but actually I find that embarrassing. But if they have a description of the height, weight, hair color, and maybe the person's going to be wearing a black business suit, then the candidate is going through the same type of questioning process. So, once we've decided on the information that we want to collect about whoever is meeting us and what the candidate looks like from two different points of view, then we might say, well, what do I have to have this object capable of in order for this to be a successful meeting? Well, something as simple as walk, talk, visualize, carry a sign, wave hands, some form of acknowledgement. These are all actions that we would like this particular object called class person to be able to perform. So what we really are doing is we're describing nouns about the object, about what the class person looks like, name, weight, height, hair color, and so forth. And we're also trying to describe the verbs that the object is capable of. In other words, the actions, walking, talking, visualizing, carrying, waving a hand, and so forth. In the world of object-oriented programming, we have a very specific nomenclature that we use to describe those things that I've just talked about. Properties essentially are the data that you need for the class. Properties are going to be those attributes that you feel are important for this particular class person object to make sense and to be useful. So you're going to record those things that you would like to know. The methods are actually the verbs that we just spoke about. Those are the actions you wish to use in conjunction with the data. You want this person to be able to walk and talk, so forth. So there are two fundamental things that are buried inside of a class object. Its properties and its methods. The properties are the nouns, in other words, the person, place, or things that we're interested in, the data, and the methods are the actions or the performances that we would like that particular object to be capable of. And in many cases, methods are designed to take the properties and manipulate them in some way to make them useful. For example, if you were modeling an invoice object, you would want to have quantity and price and description perhaps as the properties. And in the methods, you might have write an invoice, calculate the sales tax, calculate the shipping costs. So all of these are tied together in the object itself. The properties are those pieces of data we're interested in. The methods become the actions that we want that particular object to be capable of. As we said, a model exists for the objects that we're interested in. And we can think of those as drawings of the object. We're going to show the properties and methods for this class person object. Now you'll note that the value for those objects are going to be different depending on your frame of reference. The candidate is going to have one set, the interviewer is going to have another. And in this case, we show Issy is the name of the lady that's applying for the job. She's 5'9", blonde, petite. She wears glasses, is going to wear a casual business suit at the airport. Shoes will be black. She'll have a tan leather briefcase, and she's female. And then we show the methods that we hope she's capable of. She could carry a sign, even though she may not. We hope she can speak, walk, and wave her hands. The same is true for the object named Jack. His height is 72 inches. Hair color, he's overweight. Wears glasses, no. Black business suit, black shoes, overcoat, male. Now you'll note that the object, the class person objects, have the same properties, but the values for those properties are different for each one of the objects. The Issy class person object looks vastly different than the Jack person object. Now there's 4 fundamental types of object methods. In other words, we can have a method that is designed to do a specific type of purpose. Property methods are used to change the value of a class property. We just saw name, height, weight. Those are all properties. And we want methods that allow someone to interact with that piece of data. And anytime they do, they're going to do that through what's called a property method. We also have general methods. General methods quite often are used to manipulate the property data itself. In other words, I mentioned an invoice where you have the quantity of something that's purchased and its base price. And so you might have a general method that takes those 2 pieces of information, multiplies it together to give a total cost on the invoice. In the methods that we're using in our class person object, they don't directly relate to the data, but they represent specific actions that data can do. The third type of property method is what I call a helper method. And helper methods are designed for your use as a programmer. They are inside of the class box. They are not visible outside of it. So these are methods that are scoped in such a way that they're invisible to the outside world. Only you as a programmer can use them inside the class itself. You're not going to expose those to the outside world. And the reason is, if you expose something to the outside world, and then you write a new release of the software, you have to be, well, if you're writing good software, you should be backwards compatible. So anything that is a general method should be backwards compatible with earlier releases of the software that you've written. Helper methods, on the other hand, because they're inside of this black box object in a class, you can do anything you wish to those, and it's not going to break existing software because it's not exposed to the outside world. It's just there for your own use. And the final type of object method is the constructor method. Every object, every class has a default constructor, even if you do not write one. It is the feature of the language, of any object-oriented language, to create at least a default constructor method. So even if you do not write code for a constructor method, there is one that exists in the software itself. It's a native feature of any object-oriented programming language. Now let's talk about object properties in perhaps a little bit more detail. Simply stated, properties are the data that you need for the class. This is a stumbling block in program design for many beginning students because it's very difficult for you to anticipate perfectly what you need in terms of the properties to address the problem at hand. Inevitably, you'll get into the testing sequence, and your users, or the people who are interested, the stakeholders, will take a look at the thing and say, well, it would be nice if you added this feature, and you get feature creep, and anytime that you get feature creep, you also change the property list. The important thing is that the object state, or the condition of the object, is dictated by the state or the values that have been assigned to the properties. In the earlier slide, we saw that the Issy object was actually a woman whose name was Issy, and she was short, petite with blonde hair. That list of properties, once they're filled in through the process of a phone call in this case, you have defined that object state. The Issy object then takes on the state that is defined by the list of properties. You don't necessarily have to fill all of the properties in, but you fill in the list as completely as you can. So that defines the object's state. The values of the property will always determine the object state, and any change in the property value for an object is said to change the state of the object. So anytime that you do an assignment of a new value into a property, you are, by definition, changing the state of that object. Every object comes into existence with a default set of values for every property that you've put into that particular object. It is the job of that default constructor that we just talked about to initialize the state of the object. Usually, value properties such as integers, doubles, defined data objects like that, they are always initialized to 0. Reference objects, in other words, values that are textual strings, there might be some others, reference objects that are maybe even other classes, those are filled in with the value of null. And if you understand anything about pointers, a null pointer never points to anything, so what we're saying is all of the reference properties that you've defined, and particularly string data, will have null values for them. And what that means is that it does not point to any valid data. So the object value itself is empty at this point. Now, clearly, if you can't change the value of a property, you can't change the state of the object. So we need a way, a mechanism by which we can change a property value. There are two basic ways that you can change the value of a property. You can do it directly through code, and we'll see in a moment that that's usually not a good idea. Or you can do it by using a property method. And as you'll recall from our earlier slide, a property method is one of the 4 that you will find inside of the object itself. Now, what is a class? We've talked about what an object is, but we really haven't said much about what the class is. It's a template or a cookie cutter that defines an object. A class is a blueprint. It's a recipe. It is not something that you use directly itself. The definition of a class is made by the class properties and the class methods. We just saw that changing property values via a property method changes the object state. Actually, there are 4 storage specifiers, but we're only going to cover 3 at this particular point. The first is private, and that means that the scope of that particular property is limited to the class in which it's defined. Another way of saying that is, if you're not working in the class code, nothing outside of it can have access to that private data. Public data, the scope of a piece of public data is global to the entire program. In Microsoft's jargon, it's the namespace. Public data are available and visible throughout the namespace. Protected is the final one that we're going to cover at this moment. And what it means is that objects that are derived from a base class become visible to any subclasses of that. And that has more to do with inheritance, so we'll talk about that later in this class. Encapsulation. We mentioned earlier that that was the base leg of the trilogy that causes us to even play around with object-oriented programming. It's a major, most important benefit of object-oriented programming. Hiding the data within an object is one of the real benefits that object-oriented programming brings to the table. We can use the default access specifier for all class properties. In other words, when you create a class in any language, and I don't care if it's C# or Java or Perl or any other of the OOP languages, by default, a class property will be created with the default access specifier of private. And once again, that means that this particular data item is invisible outside of the class. Think about it. If a property is only visible within the class, how can you use it outside of the class? Well, you can't. So you have to write a property method if you are going to rely on the default access specifier, which is private. So keep the property methods private and then get used to writing property methods so that you have control over the state of the object. Recall, property methods are used to change the value of a property, and therefore they are used to change the state of the property. Property methods then are implementing something called a getter and a setter. As you might guess, a getter fetches the property value and makes it available to the outside world. A setter takes values from the outside world and manipulates the property inside of the object itself. By extension, then, setters change the state of an object. And if you're smart, you will only use the private access specifier for your properties, which means that you must have a setter if you wish to change the state of a property. Now, does that mean that every property has to have a getter and setter? No, it does not. Let's say that you're modeling an automobile and you have an odometer. You don't want the outside world to have access to the odometer setting. So you might make that a read-only property, which would mean that it only has a getter. And you will write a helper method. Think back to what I said about helper methods. Those are private methods inside the class that are there for you and only you. You're not going to expose those to the outside world. So you'll have a helper method that's going to roll over the odometer according to some sensor probably on the engine or the transmission or the wheel or someplace. But in that case, then you would want it as a read-only property, so you would only write a getter for it. You can also write a set-only property, but I don't know why you would do that, by leaving out the getter. So you have the ability to write read-only and write-only property methods by using only getters and or setters. But most of the time you're going to use both. Now, clearly I'm trying to make a distinction then that there is some fundamental difference between a class and an object. And it's absolutely imperative that you understand this difference for all of this to make sense. The penny will drop only if you get this basic understanding. There's a relationship. We could write a class, and if you look at the bottom of that little graph that we have, or diagram that we have up there, you'll see class diamond. So what we're interested in is building a class diamond cookie cutter. And the properties of that class would tell the angles of each one of those bends in the metal that will form the cookie cutter. You might have another one that sets the depth of the cookie cutter. You might have another one that tells the handle can only handle so many pounds of pressure, blah, blah, blah. Then that is what the class template looks like. That's what your class code will look like. And the properties and the methods will all be contained in that code for the class diamond. Now, think of your computer memory as cookie dough. The only way to get a diamond-shaped cookie is to take the class template, press it into the cookie dough, and punch out the object. So in the middle, we have the cookie dough, which is actually your computer memory. And what we're going to do is take that cookie cutter, push it into the cookie dough, and we end up with an object called a cookie. And in this case, it's of class diamond shape. So the properties of class diamond determine that it looks like a diamond cookie. We could go back, write a new class that's called class heart, bend it differently, punch it into the memory, and we end up with an object that looks like a heart. So the class then is the recipe or the blueprint that tells us how we model a specific object. However, it's not until we instantiate the object, which means taking the class object and getting a chunk of memory and molding it to look like the object, that we actually get an object in our program that's useful. So the object is actually the thing that we use in the program. The class is the blueprint that tells us how to create that object. The class properties define the shape of the cookie cutter, and it's also going to tell us not only how thick the cookie is, but we can add things like raisins to it. We could have a raisin property in the cookie object. We could have a chocolate chip object. We could have a sprinkles object, a frosting object, blah, blah, blah.